one of the biggest problems we have at the moment here. We know that the problems of climate change are dire. We have 9 planetary boundaries, and we are already crossing the limits in 5 of them. And from each 5 of them, one of the biggest collaborators to this climate problem is agriculture and the nitrogen problem. He's saying agriculture and food systems are one of the biggest contributors to climate change and one of the most difficult sectors to be adapted in the next few years. But what is the hotspot in the agricultural sector that we have to tackle first? Well, we think is proteins. At the moment, we are consuming and producing proteins in a way that is very bad for the environment. We obviously know that we have to eat less meat, but also if we are consuming more vegetables, we have the nitrogen problem. We are using a lot of nitrogen to produce these cultures, and also the European Union has a 70% deficit in vegetable proteins. What that means is that we are importing 70% of the proteins, of the vegetable proteins that we are consuming. So the European Union are looking for new alternative proteins that can be produced locally and can be produced sustainably. So we choose to work on microbial protein. Microorganisms are the unseen heroes of the biotech. They are everywhere and they can do almost everything. But we chose to focus on purple phototrophic bacteria. Why? Well, they are one of the most interesting and most metabolically diversified microorganisms in the world, and also are one of the only microorganisms that can grow using infrared light. So if we use infrared light is one of the less dense energies that we can use, so we can reduce cost in the production. So the idea is to use the autotrophic metabolism of purple bacteria. So we will be using CO2 and hydrogen in order to cultivate these bacteria that can accumulate almost 60 up to 80% of protein inside of them. So we will not only be producing a lot of protein, we will be capturing CO2, using only CO2 and hydrogen, which is readily available in the port of Antwerp. So not only we need to produce a lot of protein, we need to produce a protein that has a lot of value. So we measure the nutritional value of this protein, and as you can see, it has the same nutritional value as egg, and even a better nutritional value than soy, for example. So we designed a novel tubular photobioreactor in order to do so. This novel photobioreactor has only 2 compartments, one to mix the gases and the other one to do the illumination. And it's a modular photobioreactor, so it can be adapted in order to scale up the process if you need to scale up to a bigger industrial output. So we have developed this technology and validated this technology at the lab scale, but also at the moment we are validating it at pilot scale in a 300-liter reactor. And with the outputs that we obtained, we calculated that we can put this protein, this purple bacteria protein, in the market at more or less a similar price as the normal and traditional protein sources. So we developed a plan for the next 6 years, and the most important thing that we have to do, apart from get it invested, obviously, is to get this protein accepted as a novel food. So we need the European Food Safety Agency to accept our protein as a novel food in order to be marketed for human consumption. If we do it, we will enter a market that is growing exponentially in the last few years. We have a compound annual growth of 36%, and also this market is expected to have a market penetration of 10% by 2030. So in order to do all of this, we have a very international team. I'm Luis, she is Naïm. Quinten is not with us today. We have very diverse group of people with expertise and background in chemical engineering, environmental engineering, also food science, industry collaboration, and business development. So hopefully I got your attention, and maybe some of you want to invest in this technology.